Hello, boys and girls of St. Lucie Public Schools. I am Miss Owens, the math coach at Longwood Elementary. Thank you guys for tuning in with me. In today's lesson, we are going to work with fraction circles. I know you're probably looking at my board saying, Miss Owens, what happened to the fraction strips? In today's lesson, you will not need your fraction strips. You can use them if you like, but we're going to work on using fraction circles, which we will draw. So go ahead and get something to write on and write with, and get all of your materials ready for today's lesson. Okay. The concept, whether we're using fraction circles or fraction strips, is about equal sharing. Let's say we have 4 people and we have 4 cookies. How do you share 4 cookies with 4 people? Easy peasy lemon squeezy. I agree. Each person gets 1 whole cookie. And it looks like that. The cookies have not been broken into any smaller pieces, because if I have 4 cookies and I'm sharing it with 4 people, write this down. Each person gets 1 cookie. Now, what if I have 5 cookies and I have 4 people? How do you share 5 cookies with 4 people? Well, you take that extra cookie and you break it up into 4 equal size parts. So each person will each get 1 cookie, but each person will get an additional piece of the 5th cookie. So each person gets 1 and a 4th. Now let's talk about the fraction representation. I'm going to draw this cookie a little bit larger so you guys can see it. Let's talk a little bit more about that 5th cookie that had to be equally broken into 4 equal sized pieces. So if you look at the denominator or the bottom part of the fraction is a 4. And that's because that whole cookie was broken into or partitioned into 4 equal size sections. The top part of each fraction, or the numerator of each fraction, is a 1, because each of the 4 sections is just 1 piece. Together you get 2 fourths, and then 3 fourths, and then 4 fourths. When you get 4 fourths, you have the whole cookie again. So, if you were going to share 5 cookies among 4 people, each person will get 1 cookie and 1/4 of that 5th cookie. So let's write that down. So we know that each person gets 1 cookie. Each person gets 1/4 of a cookie. Write that down as well. Okay, So let's talk a little bit more here. So we're going to go ahead and label that piece of a cookie as 1/4. And each one of the boxes here represents the one person. So how can we write these fraction circles as fractions and not words? Each person gets 1 1/4 cookies. Is there another way that we can represent the amount of cookies that each person gets? So here I'm going to draw a larger visual of what each person gets. Each person gets 1 1/4 cookie. Well, what if I was to take this whole and part it into 4 sections? There would be 1/4 here, another 1/4, 3/4, 4/4. Each person would still get 1 whole and 1/4 of a cookie. But what if we just looked at how we can count the cookies using just fourths? So you have 1/4, 2/4, 3/4, 4/4, 5/4. So a whole and a 1/4 is also the same thing as 5/4. Each person would get 5/4 cookies. Let's write that down. Each person gets 5 1/4 cookies. So at this point, you're going to get 5 pieces of a cookie. 4 of those pieces you can join back together like a puzzle to create a whole. So you get 1 whole and 1/4, or you would get 5/4 of a cookie. Write that down. Each person gets 5/4 cookies. In this lesson, as we are using fraction circles to represent the story at hand, we are also revisiting mixed numbers and improper fractions, also known as fractions that are greater than 1. Go ahead and turn to page 25 in your workbook, and you'll see that that's where this lesson is coming from. Sharing 5 cookies equally. And then we're going to play along with it. We're going to play another version of this to get more practice. So let's just review. If you're sharing 4 cookies with 4 people, everybody gets 1 cookie. You get 1, you get 1, you get 1, and you get 1. But if you get a 5th cookie, that cookie has to be evenly broken into enough pieces so that everybody gets an equal size piece. You'd have to break that cookie into 4 pieces. Each piece of that cookie would represent 1/4, 1 of 4 parts. Remember, when you're looking at fractions, The bottom part of the fraction tells you how many pieces the whole has been broken into. How many equal sized parts the whole has been broken into. So if you take a fifth cookie and you're sharing it with 4 people, you'd have to break that cookie into 4 parts. That's why the bottom part of my fraction, or my denominator, is a 4. The top part of my fraction, the top part of my fraction, which is called the numerator, describes the part of the fraction that we're talking about. This person gets 1/4 of that broken cookie. This person gets only 1/4 of that broken cookie. So does this person and that person. Everybody already has 1 whole cookie, and they get an additional 4th size piece. So each person gets 1 1/4 of a cookie, or each person gets 5/4 of a cookie. Now remember, I've always told you, if this is equivalent to 1 1/4, and this is also equivalent to 5/4, then 1 1/4 is also equivalent to 5/4. I like this. Let's try it a different way. Now, the next example you will not see in your journal, but I would like to play around with it just a little bit more to show you guys more practice. Let's take 2 people. And you have 2 cookies. How do you share 2 cookies with 2 people? Easy peasy lemon squeezy. Each person gets 1 cookie. What happens when you have a 3rd cookie? How do you share that 3rd cookie with just 2 people? You cut it in half. Great answer. And you can cut it vertically in half, or you can cut it horizontally in half. Each person gets half of the cookie. So when there were just 2 cookies, each person gets 1 whole cookie. And when you have a 3rd cookie that you're trying to share among 2 people, there's 1 extra cookie. Each person gets half of a cookie. How much cookies does each person have at this point? 1 1/2. Each person gets 1 1/2 cookies. And how do you represent 1 1/2 as a mixed number? 1 1/2. Each person gets 1 1/2 cookies. Now, what is another way to represent 1 1/2? Can we represent 1 1/2 as in as an improper fraction. What if I took this whole cookie and I broke it into halves? How many halves would each person get? How many halves are in a whole? 2. So you have 1 half, 2 halves, 3 halves. Each person gets 3 halves. Each person gets 3 halves. Three halves cookies. Now let's make a comparison. 1 whole cookie and a half cookie is equivalent to 1 1/2. If you take the whole cookie and you cut it in half and you get 2 halves, add it to the 3rd half that you already had there, now you have 3 halves. Well, it's the same illustration. If this illustration can be written as 1 1/2, and this same illustration is also the same thing as 3 halves, then 1 1/2 is equivalent to 3 halves. So what we're looking at is how to represent improper fractions and mixed numbers using fraction circles. And we're also understanding that you can represent a fraction 2 different ways. And those 2 representations are equivalent to each other. So let's say we have 7 people. How do you share 7 cookies with 7 people? Easy peasy lemon squeezy. Just as with the 4 cookies, just as with the 2 cookies and the 2 people, the 4 cookies and the 4 people, if you have 7 cookies and 7 people, each person gets 1 cookie. How do you share 8 cookies with 7 people? I'm sorry. I wanted to do 8 cookies with 8 people. Each person will get 1 cookie. And then how would you share a 9th cookie with 8 people? You'd have to cut that cookie into 8 parts. The easiest way for me to cut a cookie into 8 sections, because I have 9 cookies that I'm sharing with 8 people. Sorry if I threw you guys off. I don't want to break the cookie up into 7ths. I want to break the cookie up into 8ths because we've been working with 8ths in our fraction strips. So let's go back and redo it. If we're sharing 8 cookies with 8 people, not 7 cookies, 8 people, 8 cookies, each person gets 1 cookie. Once we get an additional cookie, now we have 9 cookies that we're sharing with 8 people. We'll have to take that 9th cookie and cut it up into 8 equal sized parts. Well, the first thing that I'll do is to cut that cookie in half. and then cut that cookie into fourths. And then I will cut each fourth in half. And now I have 8 parts. Each part of the cookie represents 1/8. Now we do notice that the eighths are way much smaller than the half. But the more you cut a hole to share it with more people, the smaller each part becomes. So each person would get 1/8. Does each person already have a hole? Yes, they do. Each person already has a whole cookie because when we had 8 cookies, sharing it with 8 people, each person got 1. Now we have an extra cookie that we also want to share with that same group of 8 people. Each person gets an additional piece. So each person gets 1 whole cookie. And that's each person gets 1 whole. Then when we take that 9th cookie, each person gets 1 eighth of a cookie. So at this point, each person has 1 whole cookie, and each person has 1/8 of a cookie. So if I look at my whole and my 1/8, and I want to see how much of the cookie does each person have altogether out of those 9 cookies, each person gets 1 1/8 cookies. If I was to take each cookie and break it into 8/8, you'd have 8/8 and an additional 1/8. 8/8 and 1 more 1/8 is 9/8. So each person has 1 whole cookie and 1/8 of a cookie. Or I can write it as each person has 9/8 of a cookie, 9/8 cookies. Each person gets 9/8 cookies. So really quickly, before we move on, let's review. I want you guys to think of fraction circles as equal sharing. If you're sharing 8 cookies with 8 people, you get 1, 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 you get 1. 8 cookies can be evenly shared among 8 people. But when you get that 9th cookie, you can't just take that 9th cookie and give it to one person, because everybody will have 1 cookie and that one person will have 2. It's not equal sharing if everybody doesn't have the same amount. So what do you do with that extra cookie? You break it into equal size parts so that everybody can get a part of that cookie. And because there's 8 people that you're sharing that cookie with, you have to break that cookie into 8 parts. Each part of that cookie becomes one of 8 pieces. And you give all 8 of those friends a piece of that cookie. If you gather those 8 1/8ths back and you put them back together like a puzzle, you'll create that one whole cookie that you just evenly separated. Each friend will get one whole from the original 8 cookies that you had and 1/8 from that extra cookie. So each friend will have one whole and 1/8. Because we know that we can take wholes and decompose or partition them into equal sized parts, we can look at that whole. Let's draw it on the board large enough so that you can see it. We can look at that one whole cookie. Here's the 8th. We can look at that one whole and break it into parts, cutting it in half and then in fourths, and then separating each fourth in half. And now we have created eighths. 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8. So although each friend has 1 and 1/8 cookies, I can count how many eighths are just there. 1/8, 2/8, 3/8, 4/8. Let's start again. 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8, 9/8. Each friend also has 9/8 cookies. If this illustration is equivalent to 1 and 1/8, and this illustration is also equivalent to 9/8, then 1 and 1/8 is also equivalent to 9/8. Before we close out this video, I want you guys to go back and look at your vocabulary words that we recorded in one of our previous sessions. The following vocabulary words are mixed numbers and improper fractions. We know that improper fractions are greater than 1. I have more than one whole cookie here. I don't have 2 cookies yet, but I do have more than 1 because this little piece right here is more than just one whole cookie. I have one whole cookie and an additional piece. Small piece, but together, that one whole and that 1/8 is greater than 1. And that's what improper fractions are. They are fractions that are greater than 1. I like to think of them as 1 and some. If this was a 2, it would be 2 and some. We also talked about improper mixed numbers. Mixed numbers, they're called mixed numbers because they have part of this number has a whole number and a fraction. It's all mixed up. I want you guys to take a look at those vocabulary words to familiarize yourself with those terms. And when you see them, you'll know what they are and you'll know why they are what they are. And you'll know exactly what it means for a fraction to be considered improper. Quick review, improper fractions have larger numbers in the numerator than the denominator. If this was a whole that was cut into 8 parts, I know that 8 parts will make up that whole. If I have 9 parts, I have 1 more than I need for the whole. So I'm going to have more than one whole. I'm going to have a whole and some. You guys are going to take a look at page 26 in your workspace. And I want you guys to think about these questions as you're working on this page. How did you divide the cookie? How much is each person's share? How do you know each of those pieces is a fourth? Thank you guys for tuning in with me, and I will see you next time.